Hello, I'm Mikhail Zarihun, ID number 3399/12, and I handle the SQL development part of our student academic record management system. As a SQL developer, I translated the database design into a working MySQL schema, implementing server-side logic for data integrity, auditing, reporting, and reusable operations, and made sure the database performed well. I will walk you through the schema, triggers, view, and procedures and show you how the database works. Now I'll walk through the database schema and explain how the tables are connected, along with the constraints we used to maintain data integrity. Our database contains these tables: audit log, classes, departments, enrollment, marks, subjects, students, teachers, teacher assignments, users. Instead of explaining every column one by one, I'll focus more on the relationship between the tables and the important constraints we have implemented. Starting with the user table, this table stores authentication information such as username, passwords, and user roles. The roles column uses an enum type, which means only predefined values are allowed. In this case, either admin or teacher. Then we have the teachers table. Each teacher is linked to exactly one user account using the user ID foreign key. Notice that the user ID is also marked as unique. This prevents multiple teacher records from using the same account. Teachers are also connected to department through the use of the department ID foreign key, which ensures, which ensures every teacher belongs to a valid department. Next are the department tables that are very simple. Each department must only be unique in the name. Then the teacher table, the subject table. It contains a foreign key called department ID, meaning every subject must belong to an existing department. We also added a unique constraint on the subject name to prevent duplicate subjects from being created. The class table stores information about class sections. Grade name is unique, so we cannot create duplicate class names. Each class is also assigned a homeroom teacher using homeroom teacher ID. This field is marked as unique as well, which means one teacher can only be assigned as homeroom teacher for one class section. So this constraint rule is enforced directly here in the database. The student table stores student information such as student ID, name, and gender. Gender uses an enum type to restrict value to only male or female. The student ID column is unique. Even though student IDs are generated in the back end, the database, still guarantees that duplicates cannot exist. The enrollment table is next, and it is very important because it connects students to classes for a specific academic year and semester. Power off. We added a composite unique constraint using student ID, class ID, academic year, and semester. This prevents the same students from being enrolled multiple times in the same class during the same semester. We also implemented check constraint, like grade must be 9 and 11, and academic year can only be 2026 or 2027. So even if correct data somehow comes from the application layer, the MySQL database itself rejects invalid values. Coming to the marks table, it stores student scores for each subject. It connects enrollment and subject together using foreign key. We added a check constraint to ensure scores stays between 0 and 100. There's also a composite unique constraint on enrollment ID and subject ID. This prevents duplicate marks from being entered for the same subject. Another important feature here is on delete cascade. If an enrollment is deleted, all related marks are automatically removed as well. This helps keep the database clean and prevents orphan records from forming. Then we have the teacher assignment table. The teacher assignment table connects teacher, subject, and classes together. Instead of using a normal ID column, this table uses a composite primary key made up of teacher ID, student ID, and classes. This means the same teacher cannot be assigned to the same subject in the same class more than once. All three columns are also foreign keys with on delete cascade enabled, so related assignments are automatically cleaned up if a teacher, subject, or class removed. Finally, we have the audit log table. This table records happenings inside the system, such as inserts, updates, and deletions. I will be explaining more about this part when I am discussing the triggers. Overall, the schema was designed to enforce both relationship and business rules directly at the database level. We have used foreign keys for relationship consistencies, unique constraints to prevent duplicates, check constraints to limit the range of values, and enum types to restrict allowed inputs. This helps maintain strong data integrity and ensures that the system remains consistent and reliable. Another important feature I implemented was audit tracking using triggers. One of the important project requirements was being able to track who made changes, what was changed, and when the change happened through the use of audit log. To achieve this, I created an audit log table together with a series of after insert, update, and delete trigger. The audit log table stores important information about every database operation. This includes the table name, the type of action performed, the affected record ID, the previous and new value stored as JSON, the user who made the change, and the exact timestamp when it happened. Using JSON here makes the audit system more flexible because the structure can adapt without needing to redesign the audit table whenever the main tables change. Here is an example trigger for the student table. This trigger runs automatically every time a user record is inserted. After the insert operation succeeds, the trigger captures the new inserted data and stores it in the audit log table. The JSON object function is used to store a snapshot of the inserted record. Before any database modification happens, the backend application sets session variables containing the current user information. The trigger then reads these variables, so the Outlook can record exactly which user performs the action. Similar triggers were implemented for multiple tables, including students, teachers, departments, subjects, enrollment, mark, and classes. Now, to demonstrate, let us first set the current user. Now that we have set the current user as ID user1, admin, then we insert a value into the students table. Then select, using the select query, now that we have inserted a student record, we can check the audit log. We can immediately see the audit entry that was automatically generated. This includes the action performed, inserted data, the user responsible, and the time stop. Since these are after triggers, logging only happens if the original operation succeeds successfully. This helps maintain reliable and accurate audit record throughout the system. Another important requirement for this project was the production of a student report card. I implemented an automatic academic report generation using a database view and custom SQL functions. To simplify report generation, I created a view called Student Report. A view is a virtual table that stores the result of a query instead of repeatedly joining multiple tables and recalculating results every time the application needs a report. The database handles everything inside the centralized view. This view combines data from several related tables, including enrollment, students, and marks. Using SQL aggregation functions like count, sum, and round, the system automatically calculates the number of subjects taken, total mark, average score, pass or fail status, and overall student ranking. One important advantage of using a view is data abstraction. The backend application does not need to know the complex relationship between all these tables. It can simply query the student report view as if it were a table and immediately receive processed academic report data. Another advantage is maintainability. If reporting logic changes in the future, the change only needs to be updated inside the view definition rather than throughout the entire application. The view also improves consistency because all reports use the same centralized calculation logic. This reduces duplication and minimizes calculation error in the backend code. As we can see here, the database directly returns fully processed student report information. For each student, the view also includes the enrollment information, student details, total mark, average score, pass or fail status, and ranking position. This means the backend application can retrieve complete card data using a simple select statement without performing additional calculations in the application code. For ranking, I used the SQL function rank. Students are ranked within their class, academic year, and semester based on their average score. The partition by clause separates students into groups based on class, academic year, and semester, while ordered by average descent rank students from the highest average to the lowest. This allows the system to generate ranking report cards directly from the database efficiently and automatically. Now let us move on to the final part of this scheme I have developed. That would be stored procedures. This procedure automatically registers a student and generates a unique student ID. Instead of the backend manually generating IDs, the database handles the logic internally using count, lpad, and count and lpad. Create IDs like S001, S002, and the like. The next one, SP request teacher. This procedure handles teacher registration. It inserts login credentials into the user table, creates the teacher record, and links both together automatically using last insert ID, ensuring the correct relationship is created between the user account and the teacher profile. The third procedure is SP add subject for subject management. Added validation inside the stored procedure. Before inserting a subject, the procedure checks whether the department exists and whether the subject name already exists. If validation fails, the database raises a custom error using signal SQL state. The fourth procedure, SP delete subject. This procedure safely deletes subjects. Before deletion, it checks whether marks already exist for the subject. If later academic records exist, deletion is blocked to protect data integrity. This demonstrates how business rules and validation can be enforced directly at the database level rather than relying only on front end and back end validation. We have come to the end of my part of this presentation. In the SQL development, my contributions were a normalized relationship schema with strong data integrity constraints, optimal performance with strategic indexes, a complete audit trail using trigger and JSON, reusable reporting views and helper functions, and encapsulated business logic in stored procedures, and finally ensuring the database and application code complement each other very well. Thank you for listening. This is my part.